Assalamualaikum. We will talk about chromatography. Chromatography is a technique to separate mixture by distributing component between a stationary phase, solid or liquid coating, and a mobile phase, liquid or gas. As the mobile phase move, components interact differently. Some stick to the stationary phase and move slowly, while others dissolve in the mobile phase and move faster. This difference enables separation, making chromatography essential for analysis and purification. Key methods include column chromatography for packed column, gas chromatography for volatile compound, HPLC for precise liquid separation, ion change chromatography for charged particle, and planar chromatography such as thin layer or paper chromatography. We will now focus on thin layer chromatography, TLC, a simple and fast method for separation and analysis mixture.
Next, let's get into the theory behind thin layer chromatography or TLC. Firstly, let's talk about the stationary phase. This is the fixed layer where the magic of separation happens. Common material for the stationary phase include silica gel, which is polar and most commonly used, alumina, which is less polar, and cellulose, often used in biological application. The main job of the stationary phase is to hold the compound based on their polarity. Now, onto the mobile phase. This is the liquid that carries the compound up the stationary phase. Common solvent can be either nonpolar, like hexane and toluene, or polar, like methanol and acetone. Essentially, the mobile phase help compound move at different speed, depending on their polarity. Polarity itself is a key factor here. Polar compound tend to stick more to the stationary phase, making them move slower. Meanwhile, non-polar compound zip through with the mobile phase. This difference in speed is how separation works.
So, let's move on to application TLC. The first one is qualitative analysis. TLC is often used to identify and analyze compound in a mixture. It helps determine the number of components in a sample and can provide information about their purity. Number two, purity testing. TLC can be used to check the purity of compound by comparing the number of spots on the TLC plate for the sample with that of a pure standard. If the sample have more than one spot, it indicates impurities. Number three, drug analysis. In pharmaceutical analysis, TLC is used for identifying the presence of specific drugs or their metabolities in the sample. It's often used for checking the quality and quantity of active pharmaceutical ingredients. Number four, environmental analysis. It is employed to detect pollutants such as pesticide, herbicide, and other chemicals in environmental samples like soil, water, and air. Number five, food and beverages testing. TLC can be used to identify and quantity food additive, contaminant, and preservative in food and beverages, ensuring product safety and compliance with regulations. Number six, forensic analysis. Forensic scientists use TLC to analyze substances found at crime scenes, such as drug or toxins, and to compare them with no reference material. And the last one, plant and animal research. It can help in isolating and identifying specific compounds in plant extract, such as alkaloids or flavonoids, and in testing biological samples for certain compounds in interest.
For the method TLC, first prepare the TLC plate by drawing a light pencil line about 1 cm from the bottom to mark the baseline. Next, apply small spot of the sample solution onto the baseline using capillary tube, ensuring they are spaced evenly. Then, place the TLC plate vertical in developing chamber containing a shallow layer of solvent, making sure the baseline is above the solvent level. Let the solvent to ascend the plate until it reaches about 1 cm from the top, which we should remove the plate and mark the solvent front. Finally, measure the distance travelled by each spot and the solvent front to calculate the RF value for each component and compare their value to known standard to identify the component in the sample.
For the result, the first thing we do is record the RF value. for each spot on the TLC plate. The retention factor, or RF, is a crucial parameter in TLC analysis. RF is calculated as RF over distance traveled by the spot over distance traveled by the solvent front. After that, compare the RF value of the unknown sample with known standard to identify the component of the mixture. Next, we analyze the TLC plate. Note that the number of spots, their color, and their relative intensity depends on their type. Finally, document the result by taking a clear photograph or sketch of the TLC plate. For the advantages of TLC chromatography, there are 3 points. The first one is simplicity and speed. TLC is relatively straightforward technique to perform. It requires minimal equipment such as TLC plate, developing chambers, and solvent. This procedure is typically quick, with results often obtained within a minute or hour, making it suitable for rapid analysis. Second one is low cost. Compared to other chromatographic techniques like HPLC or GC, TLC is generally inexpensive. The material required are readily available and affordable, making it can making it an accessible technique for various laboratories and educational settings. And the last one is versatility. TLC can be used to separate a wide range of compounds, including organic compound, inorganic compound, and even biological molecules. By adjusting the stationary pace and the mobile pace, TLC can be adapted to separate compounds with different polarities and properties.
In conclusion, thin layer chromatography is an efficient and widely used tool for separating and identifying compound in a mixture. It cost-effective, simple and reliable, and it operates based on how the stationary and mobile phase interact, with polarity being the critical factor in the process. TLC finds its application in various fields like pharmaceutical, food testing, and forensic science due to its ease of use and rapid result. However, as with any method, it has its limitation. It provides mostly qualitative data and has lower accuracy when compared to advanced technique. But despite this, TLC remains an essential technique for quick and preliminary analysis, making it a powerful ally in laboratories everywhere.